Hi, everyone. Welcome to this episode of the Into the Impossible podcast. I'm your fearful host, Dr. Brian Keating, doing a continuing series of pandemic podcasts. Today, we have a phenomenal guest, and that is Avi Loeb, who is a legend in our community. He's the author of literally 700 research referee journal articles, several textbooks, a new textbook on the way. I think he was writing it as I'm doing the interview with him. He's so productive, but his book today that we're discussing is a popular science book that you're going to love called Extraterrestrial. And it's about this rather startling claim that he believes that the discovery in 2017 of an object traversing our solar system at an extremely high velocity, much higher than even the Saturn V rocket achieved on its way to the moon, leads credence to a claim that he makes and fleshes out in this book, that there's only one conceivable explanation for this object. It was a piece of advanced technology created by a distant alien civilization. So certainly it's a controversial claim, but it also really illuminated and exposed a dark, deep secret of the scientific underbelly, in Avi's opinion. When he had colleagues and even former students, etc., they turned their back on him, they shunned him. And I think it's really kind of a glimpse into the psychology of science, herdism, and other phenomena that you find in science where authorities can either be accepted without question, or they can be targets of approbation and maybe even a desire to take them down a peg. To get them back, or to somehow benefit from their accomplishments. So we talked about a lot of things. We talked about the full theory of how he believes this object was sent, Omuamua, from a distant solar system, what it means, why he thinks it's very likely that it is alien technology, not just a piece of space schmutz. We also talk a lot about the nature of science itself and risk-taking, and how little risk-taking and how much, not obfuscation in the sense of making up data, but lack of transparency maybe is a better word, and how that intentionally, in his opinion, is being undertaken by our fellow scientists to maybe protect and confuse the public and even funding agencies to advance certain agendas. You're going to hear he's vehemently anti, kind of extraordinary claims about theories of everything, such as we've been exploring on this podcast. And I think it's refreshing to get this view. We don't agree on everything. I pushed on him in a couple of situations, but it was a really fascinating conversation. I know you're going to love. I ask you to do me one favor and one favor only. I don't have advertisers yet on this podcast, so I'm asking you to pay me back, so I don't have to necessarily go there. Maybe I would if the right opportunity approached itself. But for now, I like to have it nice and clean, and only ask you to do one thing, and that's to leave a rating, review, and subscribe and forward the podcast to other people. Avi's really a fascinating person. I want people to hear about his controversial ideas. So please do that. Subscribe, leave a rating on iTunes, subscribe on YouTube and on iTunes or wherever you get podcasts. And I hope you enjoyed this episode of an out-of-this-world episode of the Into the Impossible podcast. Enjoy.
Any sufficiently advanced technology is indistinguishable from magic.
Anyway, today we are speaking with none other than Professor Avi Loeb, who is a legend in his own time, and he may be a legend even intergalactically. We're going to find out about that. He's the most productive. I think he's writing a paper as we speak. He's the author of 700 papers. I've read about 665 of those. I'm working on the remainder. By the end of the week, I should be done. But today we're talking about his book, a phenomenal book called Extraterrestrial. Avi, how are you doing today?
Thank you. I'm doing very well. Actually, I should say that over the past 9 months, it has been the most productive period in my life, because I was at home under house arrest, so to speak, thanks to the pandemic, and didn't have to commute to work. And most importantly, didn't have to listen to remarks from colleagues that make no sense. And so I could just work on my research and write papers and essays, and it was a very productive time. Every morning I jog out, I go to the woods, and surrounded by ducks, birds, and rabbits, and it has been a very enriching period of time for me.
Yeah, I've been trying to I've had on Ray Weiss on the podcast in the last month. I've had on Barry Barish, and I'm trying to get the Troika, including Kip Thorne, and he keeps agreeing to come on the podcast, on the Into the Impossible podcast, but he says that he can't resist how productive he's been the last few months, and he has to keep postponing our conversation ever longer. So, and one of the characters in the book we'll talk about, obviously, it was no stranger to science popularization and getting stuff done, including during very difficult times. And of course, I'm speaking about my hero, and I suspect yours too, Galileo Galilei, the first observational astronomer. He plays a big role in Extraterrestrial. Before we get there, Avi, I want to ask you, how'd you come up with the title? How'd you come up with the cover design? And what is it like to write a mass hit like this is sure to be when it comes to your role? Not inside the traditional role of a Harvard astronomy professor, but as a popularizer and communicator of science. So first of all, the name of the book, the subtitle, and the cover design. Where did it come from?
Yes, so I should say titles and labels are the least of my concerns. So I have a lot of leadership titles. You know, I'm the director of 2 centers at Harvard, the chair of national committees, and so forth. That's not really what I care about. You know, I'm driven mostly by curiosity, and just as I was when I was a child, you know, trying to understand the world. That's pretty much, from a point of view of being modest, you know, that's pretty much what I'm about. And the same is true about the book. The title, the subtitle, and the cover were selected by the publisher, the editor, and my literary agent. I am really, you know, mostly responsible for the content, and therefore I would highly recommend not to pay attention or significance to the cover. Judge the book not by its cover, but by what it has inside, as the saying goes.
Yeah. So I usually ignore that advice and always judge the book by the cover. But you're absolutely in good company, because this book is called The Dialogue Concerning the Two Chief World Systems, written by your late colleague, or the foreword written to it by Stephen Jay Gould, of course, at Harvard. But the foreword to the original edition, 1913, written by some guy named Albert Einstein. I have all these voodoo dolls here, and I'll be showing them. I had one made up of you too, Avi. You'll get to see that at the very end if you cooperate. But no.
Worried about it. Okay.
Just teasing that point. But Galileo, do you know what the original title for this book was, Avi?
No.
It was On the Flux and Reflux of the Tides in Oceans and Ferns. I don't know what a fern is. I kind of looked it up. But he was forced by essentially the index of the Catholic Church's Inquisition to change it to a much more appropriate and interesting title, in my opinion, The Dialogue Concerning the Two Chief World Systems. And I've actually seen an original copy of this. A colleague of ours, Professor Jay Pasakoff at Williams College, he donated a copy to the Williams College Library. He was, of course, a student of Donald Menzel at Harvard, who's position you have, basically, right, or as chair. So it's quite delicious to talk to you and recollect these things about great scientists, including Galileo. You make the point in the book, not directly comparing yourself to Galileo, of course, that would be immodest, and so forth. But you do compare the reaction by colleagues who should know better and should have the comity to trust somebody like you. It's not like you're a crackpot. I get emails every day. I'm sure you do too. Professor Loeb, Einstein was wrong. I can show you how he's wrong, but I'm not good at math. So if you help me, I'll split the Nobel Prize with you. And I actually talked to Harvard alum Adam Rees, and he said, "Yeah, how do you think I won the Nobel Prize?" But what do you make of this? Sometimes people attack for obvious reasons. Actually, Galileo was wrong about the tides, as you know. That was an incorrect piece of evidence. What do you make about people that have a bit of knowledge and really just kind of disregarding you and your claims in this book that we've been visited by not only intelligence but technology from an alien civilization?
Right. So the example I like to bring up is a book that was written about Einstein's theory of relativity, in the 1930s arguing that it's wrong. And there were, several tens of people signed on the book. And when Einstein was asked about it, he said, why do you need so many people? It's sufficient to have one kid make the argument and explain why I'm wrong. I don't need the crowd of people, So a crowd gives people the authority, And that was true in the days of Galileo, the philosophers, the church, they were the crowd, and he was a single individual trying to argue something that was not popular at the time. And he said, look through my telescope, look at the evidence. And the Earth actually, I think, moves around the sun. And they said, we don't want to look through your telescope. We know the truth. And they put him in house arrest. And of course, the point of the matter is that it didn't change the fact that the Earth continues to move around the sun. It just maintained their ignorance. So we can bury our head in the sand. We can put blinders and not look at reality. But the fact that we ignore reality doesn't change reality. Reality stays the same. The duty of a scientist is to find out what the world is, not to close or put blinders on our view, not to avoid looking through telescopes, not to dismiss anomalies when they are found. And, it's a lesson from history. And it's very unfortunate that in the current culture of science, this is not the guiding principle. Instead, so you might say, okay, maybe the scientific community is very conservative. And to that I would argue, great, because believing that if you reproduce the conditions on Earth on billions of planets, we now know that half of the stars like the sun have a planet of the size of the Earth at a similar distance from its star, and therefore liquid water may exist on its surface and the chemistry of life as we know it, and you roll the dice billions of times, what's the chance that we are the only ones? Very small. So the conservative view would be to say that if you reproduce the conditions on Earth, you get the same outcome. Let's go and search for it. That is supposed to be the mainstream view, and instead it's a fringe view, and the mainstream says, don't ever talk about alien technologies. Don't even speak about the possibility that we might be common out there, because we don't want to talk about it. There is a taboo, and anyone that talks about it immediately gets dismissed or ridiculed. And frankly, I don't care how many likes I have on Twitter, because as I said before, if you ignore reality, it doesn't matter. And the duty of me as a scientist is to behave just like a kid. I don't care about what my colleagues say, and, try to understand. And by the way, making mistakes is part of being a scientist. If you look at Einstein at the end of his career in the 1930s, he made 3 mistakes. He argued that black holes don't exist, gravitational waves don't exist, and that quantum mechanics doesn't have action, at a distance, spooky action at a distance. He was wrong on all 3 counts, but that's part of being at the cutting edge of science. So my point is, we should, as basketball coaches say, we should keep our eyes on the ball and not on the audience.
So I want to highlight a passage that you have in the book, which is kind of reminiscent of some statements I've made to others on the podcast, including colleagues of yours across the way in the physics department, like Kamran Vafa, who's been on the show recently. We'll get to that. But it's a statement attributed to this guy, this finger puppet. This is Carl Sagan. And I had his wife, his widow, Ann Druyan, on the podcast, and I had his daughter on the podcast as well. But he's reputed to have saying extraordinary claims require extraordinary evidence. And I've never sat around in my laboratory and said, okay, my grad students, my postdoc, let's wait. That's evidence, but let's wait for the extraordinary evidence. What do you make of that saying, and how flippant our colleagues are often to dismiss things? Maybe there's, a chance they're wrong and or a chance they're right, but to dismiss it as, well, this is so much bigger or more important, and who, by the way, gets to say what counts as, extraordinary, except for those that want to make a judgment call. So what do you make about that often used trope that extraordinary claims require we go into the special file cabinet marked extraordinary evidence?
Well, as you said, I think extraordinary is a label that is very subjective, because even if you talk about dark matter, weakly interacting massive particles might be extraordinary. to one person and quite natural to another person. So we should look for evidence. Let's put it this way. We should be guided by evidence. And we should not dismiss evidence that has anomalies just because it's not extraordinary. Because if you want to believe only things that have extremely high resolution, and you would never converge in science. Look at the evidence that was found in favor of Einstein's theory of general relativity by Eddington, right? It was very marginal for the deflection of light by the sun. And in fact, one of the experiments did not support Einstein. And right. Nevertheless, Eddington fudged it and argued that there is support. And, then general relativity was accepted. Now, would you argue, well, that was an extraordinary claim, and therefore we shouldn't believe Eddington? No, it turned out that general relativity was correct. So I would say, let's just be guided by evidence, not talk about extraordinary. And whenever there is something anomalous that we cannot explain naturally, we should discuss possible explanations. If you look at the opposite situation, where very commonly the scientific community converges behind an accepted notion, for example, that the dark matter, most of the matter in the universe, which we don't know the nature of, may be weakly interacting massive particles. That was the dominant view for decades. Hundreds of millions of dollars were invested in experiments trying to find that particle without success. Right now, there are only upper limits, constraints, but nobody blames those experimentalists for wasting hundreds of millions of dollars in trying to rule out suggestions. Because that's part of the scientific learning experience. You sometimes go in directions that turn out not to lead anywhere. And so the point is that even if the scientific community believes that something is natural and not extraordinarily speculative, it turns out to be wrong. So I think that we should remove the word extraordinary from the equation and just look at evidence. You find mainstream people that worked for decades now. These are people working on string theory, extra dimensions, the multiverse, supersymmetry, ideas that are mainstream, for which awards were given, for which people got their ego boosted, for which people feel very proud of themselves and discuss it at length, even though there is no experimental evidence. So why does that attract the attention of the mainstream, even though it's extraordinary? Having an extra dimension is really extraordinary. There is no evidence for it. Nevertheless, communities of thousands of physicists work on it. So to argue that the search for extraterrestrial technologies is speculative and therefore it shouldn't be discussed, there should be a taboo about discussing it, whereas to discuss extra dimension is completely legitimate, that to me is a distortion of the spirit of science, because we know that we exist, there is evidence for that, and therefore we should look for others out there. And how dare the scientists not work on a subject that is of so much interest to the public when the public funds science? So there is, in this equation, there is a lot of arrogance of the scientific community saying, we don't want to deal with a question that the public cares about, even though we have the technology to address it. We want to do intellectual gymnastics, demonstrating to each other that we are smart, working in extra dimensions, working on anti-de Sitter space, in which we can solve some complicated equations for which, there is no connection to reality between that and the space that we live in, which is de Sitter, not anti-de Sitter. We give each other awards for working on anti-de Sitter space, and we are extremely proud of the accomplishments that we reach mathematically in that space, give, accolades and say how great the situation is because 1,000 people are working on this. Instead of connecting it to the real world, instead of connecting it to the real people. Who cares what anti-de Sitter space properties are in the general public? Nobody. And why is this part of the mainstream when the search for extraterrestrial intelligence is not? To me, the current scientific culture has a big problem. It's geared towards improving your self-image, towards building an echo chamber around you that would make your voice louder and maintain a bigger image of yourself so that you can get awards, get into important societies, and get more likes on Twitter. But that's completely orthogonal to the actual purpose of science, which is a dialogue with nature, having experiments educate us, correct our notions. Quantum mechanics would never be thought of if there were no experiments. In fact, Einstein resisted quantum mechanics, the standard. He had a problem with that. But we would never think about quantum mechanics without the experimental feedback. So experiments help us improve our imagination. And just tossing it aside and saying, I don't need experiments. I can think about anti-de Sitter space and come up with the unification of quantum mechanics and gravity. To me, first, it's arrogant. Second, it's the wrong approach. We're heading the wrong, we took the wrong turn in the highway. And, that's a strategic decision because you're guiding herds of young scientists in directions that do not lead anywhere.
So you and I were last together in 2014. Cruising down some highway in Moscow, going to a conference commemorating the 100th birthday of Yakov Zeldovich, who was sort of a grand advisor of mine. And, we're going down the highway, and it was just a few months after the Bicep 2 affair that I describe in my book, Losing the Nobel Prize. And before we get to the topic of this sort of way that the public perceives science, the way that there's sort of this military industrial complex, or I call it the media industrial complex, where everything has to be this huge discovery because we're all terrified that the public's going to realize that basically we would do what we do for free. I mean, you talk about your childhood in such in such very simple terms, but very lovingly, tenderly describing what it was like to grow up in Israel, as you did, a very simple way of life, and almost pleasant, almost longingly melancholy for that simple time. And now we live in everything has to be this huge smash hit that could someday garner a Nobel Prize. I was told by my chair at the time, whose father was Dmitry Basov, whose father was Nikolai Basov, who won the Nobel Prize for co-invention of the laser. He was like, we hired you because we thought you had a good chance of winning the Nobel Prize. And, and how about that? We came very close, and of course, we'll get into that. But I do want to take one step back. I do think that theorists, in general, have sort of an advantage, a built-in asymmetry, in that it's easy to create theories. It's very hard to test theories. So you and I are both Jewish, and we both know the famous catechism of Judaism is the Shema, which is basically means hear, O Israel. But we won't get into theology very much unless you want to. But there's a line in there, and it says, "Do not follow after your eyes or after your heart, after which you stray." And actually, in Hebrew, you can correct me if I'm wrong, but it really means prostitute yourself, that people will basically subjugate their morality, their love of their spouse for money or for power or for whatever. And I think that's sort of a sign that the Bible is warning us about confirmation bias, and that we tend to fall in love with our ideas and feel that science is a zero-sum game. That if string theory, if there are extraterrestrials, if Oumuamua is extraterrestrial, then that's going to take away attention, dollars, research funding from five-dimensional ADS CFT. Now, my other friends are your friends, Elisa Randall, who's been on the show, and of Carmen Vafa. They'll say, no, this is not just interesting math. We actually make predictions. And I asked him, well, I didn't know that string theory makes testable predictions that we can confirm with experiment. And he said, yes, the string theory has predicted that the mass of the electron has to be somewhere between 10 to the minus 23, Planck masses and 10 to the minus 1 Planck masses. And I said, well, okay, there you go. And I said, well, the string theory predict that my weight is below, 10 to the 13th kilograms. I mean, that's true.
I mean, the question should be reversed. Can they put some skin in the game? Can they say, make a prediction that can be proven wrong? And, that's an interesting question, because Qumran Vafa himself gave a colloquium in which he said, the string theory landscape implies something about cosmic inflation. And I wrote to him afterwards. I said, great. So if we, from the microwave background anisotropies, discover that inflation occurred differently than the kind of description you gave, would that rule out string theory? He said, no, it would rule out the connection that I drew between string theory and
or a particular model. Right. I mean,
string theory will always be right. And I said, okay, well, then it's not a prediction. How can you say that something is a prediction if you can't rule it out? So you see, the point is, they are not putting skin in the game. And it reminds me of theology. Let me give you an example where theology, actually 3 examples where theology can put some skin in the game, okay? One example, my book inspired a student in the English department to pursue a PhD related to the search for extraterrestrial life, just a few months ago. And she invited me to the thesis exam. And in the thesis exam, one of the professors asked her, do you know why Giordano Bruno was burnt on the stake? And she said, well, he was an obnoxious person. People didn't like him, which is true.
It is, yeah.
But the professor said, no, actually it's because he argued that other stars are like the sun, and they could have a planet around them like the Earth, which could potentially host life. And the church found it offensive because if that life sinned, then Christ should have visited those other planets, and you need multiple duplicates of Christ, which is unacceptable. And so they burned the guy. So I said, great. I said to this professor, great. So you are offering now an experimental test of this theology, because suppose we find intelligent life on a planet, we visit that place, we see that these creatures sin, and we ask them, did you witness Christ? And if they say no, then we rule out experimentally that theology. So that's an example for ruling out a theology.
It's an expensive experiment. It's an expensive experiment.
Another example, Martin Buber is quoted by Elie Wiesel as saying, the Christians argue that the Messiah arrived and will come back again. The Jews say that the Messiah will only arrive in the future. He said, why argue? Both sides agree that the Messiah will arrive in the future. When the Messiah arrives, we can ask him or her, were you here before? And resolve the conflict. It's a very simple experimental test of one theology or the other. A third example, Abraham, when he heard a voice that told him to sacrifice his son. That's a story from the Bible.
Yeah.
Right? So suppose Abraham had a cell phone with a voice memo on it, app, if he had that app, he would just press the button and record the voice, right? And make everyone on earth a believer. Unfortunately, these apps were not available at the time of Abraham. But it's another test of theology.
But Avi, yeah.
Even for theology, you have tests. So if string theory cannot come up with such a test, cannot put some skin in the game, then what are we talking about?
I think we're talking about kind of this dominant paradigm, and just like I think that people have. I am a practicing Jew. I call myself a devout agnostic because, like Freeman Dyson, who plays a big role in the book as well, Freeman regarded the question of God's existence as definitely a puzzle, but perhaps a mystery. In other words, maybe it could be solved like a Rubik's Cube. And I told this to Qumran because his book is called Puzzles to Unravel the Universe. And I said, Qumran, do you ever play with a Rubik's Cube? And he said, sure. And I said, yeah, I can get 5 sides of the Rubik's Cube all the right color, but I never get that 6. Can you help me out? And he didn't get it. He didn't get it. But anyway, he's a wonderful person. I really enjoyed talking to him, and that he did go on the record. But the fact is, he felt this need to really subsume this. But getting back to the proving of God, I just want to take a side note. Even the thing that I like about, so I was a Roman Catholic altar boy in the Catholic Church, that I describe in my book. I was an atheist. Now I'm a practicing agnostic. But the point is, I've had a lot of exposure to different religions, and I found in my book, I actually had it as a test as well, because the as you know, the fifth commandment is kivud av va'em, so honor thy mother and thy father. It's very important. It's the first religion that put women on equal status in that level, that you couldn't just honor your father, you had to honor your mother as well. So I said about kind of this quest in my book, basically, if you could prove that inflation took place, that might lead credence to the inflationary narrative, but that might be rejected by people, right? You might say, well, some like Paul Steinhardt, our mutual colleague and friend, he might say, well, inflation predicts an infinite number of different. So even if you did provide evidence, scientists might not accept it. And so too, I said, well, one thing I could do is honor my mother and my father and see, unique among all 10 commandments, there's actually a reward promised for kivud av. Do you remember what it is?
No, what is it?
So the reward is that your days on earth, your days will be lengthened. So it's the only mitzvah that promises a reward besides shooing away the mother bird from her nest. We won't get into that. But there's 2 commandments. So I said, that's pretty interesting. It could be falsified. You could falsify the Torah if you honor your mother and father and then you die at a young age. We're not going to get into that. But my question is, looking at evidence, scientists will dismiss things, as Arthur C. Clarke, the namesake of this podcast and the center I co-direct, he said, for every expert, there's an equal and opposite expert. You know that your colleagues will say, Avi, you should stick to your lane. You're an eminent cosmologist. Just stick to that. Why do you have to get into extraterrestrial? We haven't even spoken about it, so let's get there. I want to talk about the book. Why don't you just stick to your lane? Why do you care about some piece of schmutz floating through the galaxy?
Well, actually, my lane is now the search for life, because I have an 870-page textbook coming out in June by Harvard University Press with my former postdoc, Manasvi Lingam, that describes how the search for both primitive and intelligent life should be conducted scientifically. So here is a lane. It's actually a highway, and it's the wave of the future. I think that would become one of the major frontiers. My experience from the past, I worked in areas that were not really shared by many colleagues, and then they became mainstream. Examples include the study of the first stars, the first galaxies, on which I have a textbook, gravitational wave astrophysics, imaging black holes. All of these I worked on when the community was very small, of people interested in, and then they became fads, and I don't really pay attention to the response that people. Now, with respect to objects like Omuamua that we will talk about, my point is simple. I want us to monitor the sky, for example, with the Vera Rubin Observatory that will come online within 3 years, and look for objects that are as peculiar as this one, and basically, once we find one heading our way, send a CubeSat that will take a close-up photograph of it, so there will be no doubt that it's unusual. I don't want us to suffer from lack of evidence. I want to collect as much evidence as possible, and we can do it with existing technology. But if you ahead of time have a prejudice, if you say that when you go to the beach and look at the beach, all the time you will see just seashells that were naturally produced, and you will never see anything else, then obviously you will never find a plastic bottle. I mean, if you walk down the beach, sometimes you find a plastic bottle that is artificially made. And my point is that by examining all the objects that enter into the solar system, we might find a message in a bottle. So it's a different way of studying or searching for extraterrestrial technologies, different from looking for a radio signal. And why shouldn't we do that? All the people that tried to explain Oumuamua by natural processes had to invent something that we have never seen before, like a dust bunny. There were several papers on that, a dust bunny pushed by sunlight, or a hydrogen iceberg, things that we've never seen before. So I say, okay, if it's something that we have never seen before, why not consider a technological origin? What is the problem in discussing it as a possibility? Just like weakly interacting massive particles are one possibility for the dark matter, axions are another. We collect evidence, try to figure out what's the problem. There is nothing bad about it. It's part of science, and the public is interested. How dare the scientists shy away from it?
Avi, do you remember, you certainly do, probably in the 80s, the so-called Valentine's Day event that Blas Cabrera and colleagues at Stanford University claimed to detect the magnetic monopole that existed in the universe. As I was reading your book, I felt you don't go far enough, because I know if I had access to an eccentric Russian billionaire instead of just a local New York billionaire who funds most of my research, I would say to him, "Look, Yuri, it's great to send tens of thousands of small spacecraft, as you are doing with the Starshot and the star chips, but this thing might be the only one, and it might be the only one I get to in my lifetime and your lifetime, Omuamua." So first, let me ask you, Avi, if you had his billions, we're going to get to Bitcoin later, but if you had his billions, or you could even convince him, why not just go after? That's the only thing that you know. Are you willing to bet, your stake, your scientific reputation, and say, no, let's not go to Proxima Centauri B, that might be nice, but this thing is definitely signature, not no other, you wouldn't say that. You say 91%, something like that. Why not go there? Why not go farther? Explain what's so weird about its shape. A lot of things look like, and I think there was a disservice, as always happens in your field, in this field. I'm going to call it your field now that you're writing the definitive textbook, soon to be definitive textbook. But now it's in your field. So your field suffers from, the saga, as Adam Frank calls it, prosthetic foreheads, the like aliens in Star Trek. But now or you believe this object is likely to have come from a technologically advanced civilization. Why not go after it, chase it down, and not wait for another one to happen to come by when Vera Rubin's online? Maybe this is the Valentine's Day event for extraterrestrial intelligence. Just a quick interruption in this fascinating conversation with the incomparable Avi Loeb of Harvard University. And that is to ask you to please do me the very small favor, astronomically speaking, of course, of leaving a small constellation, an asterism, as we astronomers call it, of stars in a rating for the Into the Impossible podcast on iTunes, or wherever you're watching or listening to this podcast. Please subscribe and share it with your friends. That's really the only way that I get more and more guests like today's guest, Avi Loeb. I also ask you to subscribe to my newsletter, where I'm going to send out, continuing in a series of free ebooks that I send out to my subscribers. And these involve theories of everything, the great debate in astronomy. We're going to have a separate one about alien technology, and also get a sneak peek into my new book coming out hopefully later on this year. So I hope you'll do that. Go to briankeating.com, sign up for my mailing list. I only send out one per week, and it will really illuminate for you the hottest topics in science, and in ways that you can not only learn more and get resources from the community, you can win giveaways, signed books, meteorites, and so forth, but you can also get resources to educate people in your life as well, whether it be children or friends, etc. So anyway, please leave a rating. Stars are more the better, but even 1 star and a critical review will be helpful to me. I read each and every one of them. And then, yes, please do subscribe to my newsletter, briankeating.com. Now, back to today's episode with the really unparalleled Avi Loeb. I hope you're enjoying this conversation of someone who's really completely unafraid, unashamed, and will speak his mind whenever he darn well chooses. So I had a great time on this podcast. I hope you enjoy the rest of it. Signing off until the very end of the episode, Brian Keating.
Well, the problem with chasing it, first of all, we detected it only when it was receding away from us, faster than any rocket can chase it. It's just like seeing a guest for dinner and then realizing the guest is strange by the time he or she leaves through the front door into the dark street.
I'm sorry I did that when I came over for Pesach dinner. I'm so sorry.
So the thing is that we want to catch it when it's approaching us. And we discovered it in October 2017. If we were to discover it in July, when it was approaching Earth, we could have sent a CubeSat with a camera that would take a photograph. I was actually visiting Mount Haleakala in Maui, in Hawaii, because we were on vacation with my family, and I gave a seminar at the observatory. And if we knew about the object back then I would advocate taking a photograph. But we didn't know, and so we cannot really chase it for another reason right now, even if we had a fast spacecraft, and that is because it dims, it gets fainter as inversely with the distance to the 4th power. because the fraction of light intercepting it falls off as 1 over distance squared, and then another factor of 1 over distance squared for us to see the flux, the reflected flux. So altogether, it's now 1,000,000 times fainter than it was when it was near us. And you need a big telescope on board of a spacecraft to find exactly where it is, and that is not practical. So I think we should aim to look for other objects that are peculiar. Now, there was another interstellar visitor since then called Borisov. And it's called after a Russian amateur astronomer, Gennady Borisov, that found it. And it looked just like a comet. It had a cometary tail, unlike Oumuamua that didn't have a cometary tail. So people came to me and said, oh, look, Borisov looks just like a comet that we have seen before. Doesn't it convince you that Oumuamua is natural? And I said, look, when I went on the first date with my wife, she looked special to me. And the fact that I met a lot of women afterwards didn't change my opinion about her. So why should I change my opinion about Oumuamua just because we saw a comet?
Right.
And so the point is that we should be exploring other objects that are weird and find them before they pass us and try to. Now, there was another peculiar object I should mention found in September 2020, just a few months ago. And that object was given the name 2020 SO by the Minor Planet Center, an astronomical organization that gives names to objects in the solar system.
Harvard, right? Harvard runs it.
Harvard, yes, exactly. And they gave it the name of 2020 SO. And then astronomers noticed that it moves in an orbit that is not very different from the orbit of the Earth, so it's bound to the sun. And they went back in time to see where it came from and found that it actually came from the Earth in 1966. And then they looked at the history books and realized, oh yeah, there was this lunar surveyor mission, lunar lander that failed, but there was a rocket booster that was kicked into space, and that is probably the rocket booster. Now, that object, before it was recognized that it's that rocket booster, the astronomers figured that, in fact, it has an extra push because of the reflection of sunlight. So it's not just the force of gravity that dictates its orbit, but there is an extra push, which is similar to Oumuamua. And so my point is, this is a hollow object, very thin. It had there was an extra push from reflection of sunlight that we could recognize, and we can tell the difference between that and a rock. We can tell that it's artificial. And in this case, we know that it was made by us. But in the case of Oumuamua, it doesn't look like a rock and was potentially made by another civilization.
When you think about the civilization that might have created it, do you think that they targeted the Earth? Because I think that would alter my priors, right? If you were trying to send something to, Proxima Centauri B, I mean, you make the case how large a technical challenge it is, and I don't think you can just say, well, their technology is so much more advanced if they can create something that can travel these vast distances. But I think, it changes the way I would think about it. And I wonder how you think about it. If it was targeting the Earth, do you think that there's reason to suspect? Because you don't really come down one way or another in the book. But
I don't think it was targeting the Earth. And the reason is simple. I think that we are common. If you open the morning newspaper, you realize we are not very smart. We're not very... we make a lot of mistakes all the time.
Speak for yourself, Avi. Speak for yourself.
No, my point is also, if you imagine us coming from the soup of chemicals that were on Earth early on, and you look at recipe books, you can start from the same ingredients and get very different cakes, right? And what's the chance that this soup of chemicals made the best cake that you can imagine? It's probably very small. And if you cook the same chemicals on other planets slightly differently, you might get much better cake. So I would argue that we are, sort of an average kind of outcome, and that there are much smarter beings out there. And, when you walk on a sidewalk and there are ants under your feet, you don't pay attention to every ant. It's not very significant. So I don't think we deserve, let's put it this way, we don't deserve the attention. I don't think they would spy on us because first of all, we are so common and so uninteresting and so foolish, if you look at human history, that we would not attract a lot of attention. So I would assume that, we are not worthy of their. And also, if there is a very advanced civilization that, let's say, is 1 billion years old, technological, they probably created a cocoon, a habitat, where they have everything they need, and they would close themselves off. I call it social distancing on a cosmic scale. If you have everything you need, you don't want invaders, you want to reduce the risk, you close yourself. You don't look after others. And, in that case, you might say, oh, we will never find about them. But that's not true, because they have to throw their trash. They produce some trash, and we can be just like those investigative journalists that search the trash of celebrities in Hollywood to find out about their private lives. We can find that trash.
Another thing you talk about a lot in the book is being humble. Obviously, that's a biblical virtue as well. I wonder, though, what would it really mean? And I can't resist, because, I know you are a scholar of many things, not just science, but also you think deeply about philosophy. And in fact, you wanted to be a philosopher, as I learned from the book, and maybe theology isn't so far off. I look at the case of and I mentioned this in my book as well. I wrote a book about the detrimental effects that the Nobel Prize has on scientists and the public's perception of science, that we elevate people to the status of gods. We know their names to the extent that we know any scientist's names. It's Stephen Hawking, Neil deGrasse Tyson, Bill Nye, and probably Avi Loeb, but that's about it, right? So and then a kid sees that and says, I'm not Avi Loeb, I'm not Einstein. And I said that to Jim Gates, who wrote a book about Einstein, and he's like, Einstein wasn't Einstein in the beginning. And here's someone I look up to like that. Now, in the case of the Nobel Prize, people aspire to it, and it makes funding decisions. It makes decisions for entire fields, for departments, as I already mentioned. And so I wrote this book. I saw the impact that it has on my field of astronomy and physics in general, and it was pretty negative. And then I saw Duncan Haldane came to UCSD to give a colloquium, because he was a professor here when he did the work that later garnered him the Nobel Prize in 2016. For the prediction of topological matter with strange properties. He brought his actual Nobel Prize. He left it with me. No, this is some gelt from Hanukkah left over. But but he brought it, and everybody was there, and everybody wanted to, they didn't care about him. They wanted to touch the Nobel Prize. They wanted to feel the Nobel Prize. They took selfies. I took a selfie with it, Avi. I come down like I hate the Nobel Prize. No, I took a selfie, and I realized, we're not so different from the Israelites, who, after they supposedly witnessed the splitting of the sea and God's miracles tenfold over, destroying their enemy and liberating them in redemption, they worship a golden calf 40 days later, right? So how far are we from this? In other words, how much do you think that people would really change how they live their daily life if they discovered? I mean, we already know, and I think you talk about this in the book. If you look at a chimpanzee and you assay their DNA, it's about 99 point something, percent identical to human beings. But nobody walks around and says, I'm just like an ape, I'm a hairless ape. I should have some humility. Why do you expect it would be different if we discover Oumuamua is alien technology?
Well, two things I wanted to mention. First of all, I completely agree with you that science should be driven by curiosity. It's about the dialogue with nature, getting an answer from nature, through experiments, and that will educate us, improve our imagination. Nobody would have thought of quantum mechanics out of the blue. And the second is that being an astronomer teaches you modesty, because you realize that, there are 10 to the 20 planets like the Earth in the observable volume of the universe. Even if you conquer a big piece of land on Earth like emperors or kings did, it's just like an ant, wrapping its legs around a single grain of sand on the landscape of a huge beach. It's not very impressive. There is no way for us to be impressive, even if we demonstrate our superiority relative to another person. That's ridiculous. This ambition of showing off, getting awards, like, what are we talking about? Are these really awards? I mean, that's nothing compared to understanding reality, figuring out what the universe is. It's not about us. Doing science is about nature, trying to figure out nature. Let's do that. Let's focus on the real thing rather than focus on ourselves, because if we focus on ourselves, then we do intellectual gymnastics. If you go to the Olympics, what do you see? You see people running 100 meters. Is there any significance to the distance of 100 meters? No. We could have defined it to be 50 meters. We could have defined it to be 20. Just like the anti-de Sitter space, it's something that we decide about, and then we test the ability of people to do it the best, and it bears no cosmic significance. It's about us, testing us. So you can, of course, give jobs to people based on how well they do under these defined circumstances, but it says nothing about nature. If you want to understand nature, you need to go out, collect data about nature, and figure out whether your ideas are right or wrong. You need to put some skin in the game. Mm-hmm. You need to allow yourself to be wrong. If you don't allow yourself, for example, Alan Guth, speaking about inflation, so I asked him at a public discussion, I said, is inflation falsifiable? Can you prove inflation wrong based on an experimental fact? And he said, it's a silly question. I said, what do you mean it's a silly question? Mm-hmm. Any theory in physics is supposed to be testable, right? And he said, well, it's just like a part, it will always be right, irrespective of what the experiment is. I can find a model that would accommodate it. So I have a problem with that, because then you're not learning anything new. If you can tailor your theory to fit any fact, then you're not really learning anything, because anything. So anyway, coming back to your point, let me make my, so the universe tells us that we should be modest. Okay, and we should accept that and not value prizes so much. I think the biggest thing for us to think about is something that you can find in the Bible, which is the story of Noah's Ark. Noah was worried about the great flood, destroying life on earth. And so he decided to build an ark. And the dimensions of the ark are specified. By the way, they are very similar to the dimensions of Omuamua.
Yeah, I noted that.
And he wanted to put animals on the ark, like that, so that life would be preserved during the Great Flood. That's the storyline.
Yeah.
We should think along the same lines, because currently all our eggs are in one basket here on Earth. And if some catastrophe happens, like, for example, we don't take good care of our climate, or an asteroid impacts us, or in a billion years, the sun will boil off all the oceans on Earth. Then we will lose everything that is precious to us. Mm-hmm. And how do we build a Noah's Ark that will preserve? If you look at the printing press that was invented by Gutenberg, the big innovation was previously there were very few copies of the Bible. And therefore, each of them was extremely precious because it was handwritten. But once the printing press came along, lots of copies were produced, and then if one of them gets damaged, no worries. So the same, if we were to establish copies of life on Earth elsewhere, then we would face less risk if something bad happens here. And how can we do that? We don't need to build a huge spacecraft that can accommodate elephants, whales, birds, and so forth. All we need to do is take a CubeSat that has a very advanced computer system in it, put a 3D printer, and learn how to produce synthetic life with the 3D printer out of the raw materials that it finds on another planet. So we just need to feed the computer with the information about the DNA of those animals that we want to reproduce. It goes there, uses the raw materials, and makes life the way we want it. And once we make those, just like the printing press, once we make copies, then we would be less worried about what happens here.
Yeah, hopefully won't.
That's the biggest thing for us as a civilization to think about.
Yeah, I mean, hopefully, though, when I plant the tomatoes in my garden, I throw away the seed package. I hope there'll be some use for the originators of the DNA and that create this interstellar Noah's Ark. I do want to touch just on one thing you said before we kind of wind down with some of the standard questions I ask all my guests who honor me with their presence, as you are today. And that's with regard, again, to this confirmation bias that scientists seem to have, but don't admit that they have. And my theory is that scientists are, even if they're atheists, and 90% of the National Academy or National Academy member, they are either non-believers in God or they don't actively profess any sort of religion. Maybe they don't deny it, but the number of agnostics is very small as well. Anyway, something like 90% don't actively affirm the existence of God. And yet, you hear statements from people like Guth, like Linday, like other people, and Lawrence Krauss, Max Tegmark, who's been on the show, and they'll say all sorts of things that, if the multiverse is true, and we have no reason according to, so the syllogism is, Linday says that it's almost impossible not to have the multiverse if you have inflation. Guth, you just told me, basically says it's impossible to avoid inflation. Therefore, there is a multiverse, according to most people. And then Lenny Susskind, who's been on the show, also thinks because string theory provides evidence, in some sense, for the existence of a spectrum of different habitable or it.
But they should put some skin in the game. They should say, if this is found experimentally, if you go with the Simons Observatory and you find something, okay, can you rule out any of their models?
No. No, I've had this conversation.
If the answer is no, then, how can they argue that they make predictions or that this is a scientific, this is not part of our scientific...
Well, here's a counter argument. I talked to Martin Rees this past Monday, and he said, imagine that you were trying to prove that the Earth is the center of the universe. So you take Michelson-Morley and you look at the Michelson-Morley effect, and that shows you that the Earth is stationary with respect to the ether wind. Okay, so that was his example. My example is...
But that's one experiment. We have a lot of other, so you might be misled by one experiment, and there are many examples for that, where one experiment gave the wrong impression, and then there were other experiments that falsified the interpretation of that experiment. Fine, so we can be wrong along the way. That is legitimate. You can have a worldview that is completely distorted, that is supported by one experiment, okay? But then you continue to test it. It continues to put some skin in the game, and you check it again and again. So that's
why I feel like, again, not with all respect and covet to you, I have to say that I don't feel like you really believe that Oumuamua is real. Because if I knew that what you just said, you said two things today. You said that it wasn't targeted at us. That means it was random by definition. It wasn't intentionally sent to us in likelihood. That means that the chance of it happening again could be extremely small. It's not vanishing, but at least if I know there's a string theory habitable universe and it's in the constellation Aquila and I can look there and I'll see it, it'll be hard. It'll cost me a lot of money. I would do anything to see that. So why don't we go after and chase it with a star chip?
No. My point is, if it was not targeting us, the conclusion is different. The conclusion is that there is a population of objects because with pan-stars, we surveyed the sky for a certain duration, a certain length of time, or let's say a few years, and a certain volume that we were sensitive to in terms of objects of this size reflecting sunlight. From that, if you assume that it's a member of a population of random objects, that we don't live at a special time when pan-stars was able to detect just the one object that is in our entire neighborhood, if you assume the Copernican Principle, which says, things are sort of the typical, that they are typical at the time that you observe them, then it means there are many more, okay? And it means that LSST on the Vera Rubin Observatory will find once per month such an object because it's much more sensitive. So actually, I draw the opposite conclusion in the sense that it's a very testable hypothesis in the sense that there should be many of those if it was not targeting us. If it was targeting us, there may be very few, indeed.
Yeah.
Because then it came on purpose, but then you ask yourself, what's the chance that we happen to live at a time when one such object comes close? So you violate the Copernican Principle again in terms of time. Anyway, so altogether, I think the conclusion is let's collect more evidence. And I wouldn't say that I actually do think that, we should base our assertions on evidence rather than prejudice. And the only way to avoid it is by us saying we know the answer in advance.
Mm-hmm. Well, yeah, I remember hearing it, when it first came out and you first started to alert the world to this possibility that was startling. You know that it is, and it's an audacious claim. And I remember you saying things like, we have to gather more evidence. And I was like, well, how are you going to do that if it's...
With LSST, we can monitor the sky. Now,
sorry, Avi, just to put one pin in that. I mean, if you got a letter from some force, God, I'll call it God, so this is the only one, what would you do? In other words, that's the ultimate skin in the game, in my opinion, is you believe in it so much, your skin is fully on the skin of this object.
No, but that violates the Copernican Principle. So I believe in the Copernican Principle.
Yeah.
The Copernican Principle has two aspects to it. One, that we don't live at a special time. Okay, so even if these objects are rare, still there is a certain frequency by which such objects pass near Earth, because it's very unlikely that if they pass once per million years or once per billion years, that we would live exactly at the time. You would look at the sky with pan-stars exactly at the time when it comes close to Earth. That's very unlikely, and therefore I don't accept that notion that we will never see anything else like it in the future.
Would you give Would you give a limit? Like when would you give? At some point, you might say, "I believe this one is extraterrestrial. We haven't seen any in X number of years. Let's go after Omuamua." But what would that be? In other words, when will you say that your hypothesis? What would it take to falsify your hypothesis, Avi?
So when LSST looks at the sky in 3 years, after a year or two of not finding anything like Oumuamua, then I would say maybe it's special. But before that, I would not say that. Now, you also brought up the issue of God and the science, and I wanted to mention the fact that Einstein accepted the concept of God advocated by Spinoza, because Spinoza associates God with nature, and to me, the most startling fact about the universe is the laws of physics that we uncover by experiments here on Earth appear to apply all the way to the edge of the universe, the cosmic microwave background and so forth. And that's remarkable, because, when you establish laws in society, you see lots of people violating them. But how come the universe as a whole is so organized? And, that order to me is fascinating.
Mm-hmm. Yeah, I asked people like Sean Carroll once, and I'll ask you, I can't resist. I said, what do you think the odds of the multiverse being true are? So what do you say?
I say I don't want to discuss this question because I cannot test it.
Okay.
We can waste our life just talking about things like how many angels can sit on a pin. And people did waste their life doing that. We have a limited time here on Earth. Why not ask questions that we can answer?
Right. And then I asked him, just for completeness, what do you think he said about 50% odds that the multiverse is true. And then he said, and I said, well, what are your odds estimation for the existence of God? And he said less than 1%. So I found that interesting.
But the point is, anyone can say anything.
Yeah, exactly. There's nothing, right. It's completely.
So there is a lot of noise in the system if you just have no evidence to support any of these statements. And my point is, let's reduce the noise. Let's just talk about signal, right? Mm-hmm. So the signal comes from nature itself. Let's look at the evidence and try to understand what it means. Mm-hmm. Otherwise, we can sit here forever and talk about possibilities that are not realized,
right?
Like anti-de Sitter space, for example.
Exactly. Talk to your neighbors across Harvard Yard there about that. Before we turn to the final questions, I just, again, cannot resist the temptation to discuss almost anything with you. But yeah, the notion of kind of publicity in science. So recently, I was asked to comment on this discovery of phosphine in the clouds of Venus. And, it was a major press conference. There were leaks about it. It reminded me very much of Bicep 2. And actually, I had on Sarah Seeger on my podcast, and she talked about the events of that discovery and follow-up that's ongoing. But I basically made the case that, I think press conferences turn science into spectacles, and I don't really feel like they have a great place in science. In fact, even like supposed gold standard of science is peer-reviewed journals. I mean, those have only been around for about 100 years. It used to be a bunch of white guys got together in the Royal Society. They did an experiment, something blew up, or they cut open a frog, and that was it. And then finally Nature came along. But, as they say, just because it's published in Nature doesn't necessarily mean it's wrong. No. And we had things things published, and of course we had to. What do you make of that? You were chair then, and you helped to set up the press conference at Harvard that we announced it in front of Nobel laureates in the audience and to a chorus of both. I found it interesting because on that same day there were people like Lawrence Krauss saying this proves there's no God because there is a multiverse, and then there was people from the Discovery Institute, which is a Christian apologist organization, and they were saying this proves there's a God because he fine-tuned the universe. So anyway, what do you make of this relatively recent phenomena, which was first invoked in my mind, in the 90s, well, certainly in the 80s, but then, most prominently when Clinton announced in the Clinton administration that we had found evidence for Martian meteorites in the Allen Hills meteorite of, so it's extraterrestrial. Then there was extremophile life found in Mono Lake here in California and other things. Anyway, it seems to have a lot to do with press conferences and extraterrestrial life.
I think it's a symptom of the way that the system operates, by which the idea is not to expose anything to the public until the group of scientists that collects the evidence is confident that it can come out. The truth is, that the king is naked, right? That in fact, the process of science is by trial and error, and there are many, times when we are mistaken. And so we should not elevate an announcement to the level of certainty and then make a press conference. We should show how science works. And what I mean is, if, for example, in the context of BICEP, if the group were to announce its results and then other people would criticize it, and then there would be some additional data coming in, let's say for Planck and so forth, and we would sort it out. That that's the process by which science works, and there is nothing wrong about it. Again, one of the motivations was that there could be a Nobel Prize attached to such a discovery, and you need to come up, in a public way, in a well-organized way, so that others cannot scoop you. And, so all of these motivations are unnatural to the process of science. And my point is that science is done by iterations. We should not portray an image to the public where we never make mistakes. Some scientists told me, that's really bad if something turns out to be wrong, because then the public will not believe when we tell the public there is global warming. They would not believe us, because here is, an example where scientists are wrong. Well, the truth is, this king was naked for a long time. The fact that you say the king is dressed doesn't make it, because if you look at the history of physics, there were many instances where people made statements that turned out to be wrong, including Albert Einstein, including famous people. And so the point is that science is all about a learning experience. We are trying to figure out what nature is. And sometimes we make the wrong inferences. Mm-hmm. And the only way to correct that is by getting more data, rather than closing ourselves in a room, figuring out something, and then once there is consensus in the room, coming out with a big announcement so that we can get a big prize. Yeah. That's not the natural way of behaving.
I agree.
The natural way of behaving is always making things as tentative statements based on the data we have. That's the best conclusion we can reach. And let others criticize it. And, with Omuamua, that's exactly the approach I'm taking. I was in the military at a young age, and there was this saying that, one soldier sometimes has to put the body on the barbed wire so that others can go across it in a battle. And as far as I'm concerned, I'm willing to put my body on the barbed wire and get the critics to attack me, just so that younger people in the future will benefit and be able to speak freely.
Great, Avi. That's a really beautifully expressed sentiment. I just want to say, for your consideration, you shouldn't rule out using high-resolution microwave background experiments to look for these objects as well. Simon's Observatory, one of our plans is to look for Planet 9 and transient phenomena. And so don't be so visual spectrum centric, as I know you have a great deal of experience from the radio down very low megahertz level college radio stations all the way up. Well, Avi, I can't thank you enough for going into the impossible with me. I want to wish you all the best of success wherever the book may take you. And since you don't follow, are not a big presence on social media, I will do my best to promote you inside and outside of all these video venues. And otherwise, I will let you know when this comes out. Anyway, for now, I wish you Shabbat Shalom, because you must not work 7 days a week. That's the only thing I would implore you not to do. You're so productive. You get so much done. But we all need a day of rest. I command my graduates. The only thing I bring religion into the public sphere, I say, I command you, you may not work at least 1 day a week. I don't care what day a week it is. You need to rest. You need to recuperate. But I know you're going into a very busy period for you. I wish you stamina. I wish you resiliency, but I know you already have it. So I wish you all the best, Avi. Thank you for coming with us on the show, Going Into the Impossible.
Thank you for having me. It was a real pleasure.
Any sufficiently advanced technology is indistinguishable from magic.